Hi, I'm Kate. Um, Hi, I'm Kate. I am. Hi, I'm Kate, and I want to talk about our Agitcrop Perma-industrial home design. Um, it's it's a confusing design, so I've been fighting with exactly how to do a video for it. I keep trying to break it down into its sort of different components. But then if you look at it from any one design perspective, it's a sort of can't see the forest for the trees situation. So I think I've determined that the first video I put out about it is going to have to be about the marriage of the timber frame and the mushroom wall panels. What is a perma-industrial home design? What's perma-industry? If you've seen the permaculture food forests, people talk about how it can save the world. It does all this for carbon capturing and feeding people and biological diversity and how good it is for the planet. And then they say we could feed everybody. And that's wonderful. But the crises that we're facing right now, the housing crisis, climate change, homelessness, the fact that most people can't afford transportation and the overwhelming amount of transportation in urban environments. There's a lot of things going on. Deforestation for the sake of building homes. People can't afford. So what we decided to do was try to take a permaculture food forest and figure out how we could build a home within the scope of keeping it a permaculture forest. How can we make building a home actually good for the environment? How can we make building a home affordable to people who can't afford a home right now? How can we make a home affordable to people who can't afford to buy land? Because even if you can afford to live in an apartment, you probably can't get a loan for land right now. This is an issue. So we're trying to address a myriad of problems with one sweeping solution. And if you look at all of the moving parts and all of the essential ingredients in a permaculture design, then you'll see, if you look at all of those different trees and then you stand back and you look at them all together and see that it's a forest, then it finally makes sense. In this first video, let's just talk about the two big flashy ones that are probably the most weird. Stay. You just stay. You hold on. I have to go put my dog down. Not like put him down, like get him off the bed because he's old and his legs are short. I'm sorry. The chair is mine right now. I never sit in this chair. This chair is my dog's chair. You good, buddy? All right. I think he's all right. So where were we? The weirdness of the house design. Okay, so the way we're building our prototype right now will be originally on a trailer. So we're designing it within the constraints of a tiny house on wheels in the United States. 8.5 feet wide, 13 feet tall max. I think it's 13.6. I'd have to look at the diagram. It's not designed so that it has to be on a trailer or it has to be 8 feet wide, or it's a modular design, which you can achieve with a timber frame as long as there's no metal components. The timber frame is sort of an old-timey thing to fall back on for a tiny house. The weight is actually almost exactly on par with a stick-built structure. If you're counting that it is clad in, it's got OSB, it's got plywood, it's got hopefully not drywall. Most people are not putting drywall in their tiny houses because it's incredibly heavy. But it's Baltic birch, if you're fancy. And then whatever insulation is in there, which is probably not a very environmentally friendly insulation. There aren't a lot of environmentally friendly options for insulation, as it is sandwiched between plywood and over 2x4. By doing a green wood timber frame, we're embracing something that was left behind during industrialization. After World War II, so many people came home. There were so many babies being born. We had to look at a way to not take so much time to build our constructions. We needed houses, we needed schools, we needed hospitals, so much. And to do it in traditional methods would have taken a lot of time. It was a good idea at that time to industrialize the manufacturing of construction materials. It was prudent, but we grew to rely on that so much that a lot of these older methods, most people don't even know they exist. But why are we choosing to do a timber frame for this? It is so that we can incorporate another material. It's not, oh, we just wanted a timber frame because it looks fancy. Yes, it does look fancy. It looks gorgeous. It is incredibly sustainable when done right. It can be site sourced and you can put in your own labor. There's all these things. Not using industrialized construction materials does a lot to reduce the carbon footprint. But the reason we actually are choosing to do this is because it's the right way to marry into another amazing material, and that's mushroom insulation. You've probably heard about mycomaterials, mushroom materials. It's not made of the mushroom, it's made of the soil-based, the hyphae, the mycelial network that grows through soil and decaying material. It's very strong. It's made of chitin, the same stuff that bug shells are made out of. It's very strong. And labs all over, scientists all over have been playing with ways to make this new amazing construction material because it is carbon negative. It grows in the ways that you would need it to grow to use it for construction. It grows from agricultural waste. So not only is it carbon negative on its own, but the fuel that it utilizes is waste of our current system. I'm just going to let this car with the incredibly loud muffler go by on the highway. So we have this amazing, this wonder material. One of the areas that mycomaterials is doing really well is as an alternative form of packaging. You grow the mycelial network in a substrate. That substrate is generally made of agricultural waste or seeds, rye berries. It can grow on straw. It can grow on wood. It loves anything with cellulose and lignins, and it turns that into the chitin. Using these agricultural wastes, you create this substrate. You can shape the substrate that you then inoculate with your completely colonized, in the case of blue oyster mushrooms, we're going to be using rye berries. So you get it growing really good on these rye berries. It's like baby food for mushrooms. And then you inoculate your wider substrate. If we grow that in a form that allows for plenty of gas exchange, then we can grow the mushroom clear through the substrate. And this is not the same as growing mushrooms that you would eat. In fact, if you look at this, we're intentionally failing to grow mushrooms. Instead, we are opting to work to fully colonize our substrate and make as much of that mycelial material as possible, and enough of those interwoven hyphae that are made of that strong chitin. We want that to be as thick as possible and not grow mushrooms. So once you've done that, you end up with what really looks like, if you're doing it nicely, it doesn't look much different than a textured drywall with eggshell white paint over it. It's at worst, it'll look like it's plaster, messy plaster. It really, if you've grown mushrooms before, put out of your mind that nasty piss yellow mycelium that you get when you colonize it all in a bag for the purpose of fruiting it into gourmet mushrooms. These are not the same things. Instead, take yourself down the rabbit hole of looking into how mycomaterials are being used for packaging right now, and imagine that as your wall material. So with a timber frame, we do not have to put our insulation between the timbers like you do with 2x4. You've got a bunch of 2x4s and you've got all this insulation packed into these weirdly shaped nooks and crannies and then sandwiched with plywood or drywall or whatever you're choosing. We're not doing that. You have your timber frame, it will be completely exposed from the inside. All that beautiful woodworking and joinery you get to enjoy. It does not get hidden in a wall. The wall goes on the outside, and then the part of the reason that we chose to do a timber frame is so that we can put another section on the other side of that with battens and lath, which is, if you've ever been in a home that was prior to drywall, if it was a plastered wall, you peel the plaster off, you see all those wooden slats. That's part of it. And it goes on the outside of the mycelium paneling, which can grow about to 4 inches. That's about as thick as you can get to suitably colonize your substrate so that it is indeed nutritionally wasted to the mushroom all the way into the center. So if it's grown correctly and you bake it off at 90 degrees, it does not take much, then there is no living fungi in there, and there's nothing for it to start growing on again. So it just becomes this inert material. And it's really an amazing material, especially if you consider a lot of the worries that the houses face right now. Fire is a problem. Myco-paneling does not burn. It is flame retardant. Well, it's not flame retardant. It just won't light. It will smolder a bit. It won't light. So when you see big, huge house fires just explode and it's just hot and noxious, it's because of that insulation in part. Also, plywood burns really well and releases some really awful gases because of all the adhesives that are used in putting that peeled tree back together. And you're going to avoid all of that. So the entire timber frame structure is encased in this flame resistant shell. We have the battens and the lath on top of that, and then over that goes your envelope, and then I've designed it so that you can use shingles, because that's one of the fussiest and most oddly sized siding options. So I planned the placing of the lath for the application of 14-inch cedar shingles. I'm still optimizing it. There's still some changes to do before I go into building forms for these myco-panels. But the point is to be able to build small forms, about 2 feet by 3 feet, 3 feet by 3 feet, some 2x4 in there, and by 4-inch thick. You build those forms and you grow your mycelial panel in there, and it's formed so that it actually nestles between all of these wooden components. So then you've got 4 inches between your green wood timber frame and the siding, and all of that is sandwiched together and held with large, generic bolts. Goes all the way through. That bolt and that spongy mycelial panel enable enough room for the green wood timber frame to do its shrinking and not mess with your siding. There's just enough flex in there. If you're working with something that's going to expand and contract, anything that it attaches to that is static and will not move, you need to plan for the wood to be able to move around that. Otherwise, it will break itself. So that's another reason why our modern industrially manufactured construction materials came about, is because we also wanted to start putting things together in a standardized way, and we wanted to use screws and nails and metal plates and your strong ties, and we needed a material to use with all of those that didn't require knowledge and skill to understand how to. We just wanted somebody to be able to drive a nail into a thing and it's done. You can do that with plywood. You cannot do that with solid wood. It is not plywood. Plywood and OSB and particle board, that is a wood product. It is not wood. It is akin to calling Jell-O meat. Yes, it came from a meat creature. It is no longer meat. So, but by going back to this older method of construction, which is much better for the world around it in so many ways and much more accessible, right? We live in the Pacific Northwest. Anywhere along the northern hemisphere, conifer bearing hemisphere, this plan could be possible. So by turning to that older way, suddenly we do not have to rely on the mycomaterials to be the structural component of the building. People working on mycomaterials, making blocks out of it, making big sheets out of it, only to find out that it has a dulling effect on blades, and so it's kind of cost prohibitive to grow it in a 4x8 plywood size sheet and then cut it up. That's why you're not seeing it in our 2x4 constructions. It is too expensive to grow it in a sheet size and then cut it up. So it's just not going to make it into the houses that we're building now. But if you marry it with something as strong and enduring and eco-friendly as a timber frame, then it doesn't have to do the double duty. It can just be your wall surface and your insulation and your acoustics. And if anything does happen, if damage comes to the building, it's compost. It doesn't have to go to a toxic area in a dump because it's full of adhesives and it's going to let off toxic fumes or poison the soil. It literally becomes garden soil. So if you put these two things together, it's revolutionary. There's some other design things that we should talk about. Why the curved roof? That was a choice. I didn't just say, hey, I want to do it the hardest way I can possibly think of. It was the right decision, in part because it gives you so much more room in the building. It is the best use of space for such a small space. It's not as heavy as a steepled roof. There's just more wood in a steepled roof for the same amount of strength, because there's a joint in the middle there, for the same amount of strength that you're going to get from a curved beam. I can reduce weight that way. There's another reason. My big hope of this being something that grows and takes off and spreads and helps people in need is that we turn it into a vocational training program. So what I want is for people to learn how to build this house, and when they leave, they're not a carpenter, they're not a contractor, they're not in construction, they are a woodworker. They know everything you need to know about how wood behaves from a tree to a finished item. In order to get the full curriculum that a woodworker needs into one house, we had to bend something. We needed bent components. Until you've successfully bent wood, you haven't won over the wood. You need to know how to make it do what you want it to do without beating the hell out of it. And then there's jig building. You need to know how to build all the jigs. One does not just make something out of wood. All right. You have to make the thing to help you make the thing to make the thing. There's a lot of hidden steps in woodworking. Lots of jigs. You don't go into a furniture maker shop and find wall space. There isn't any. There's weirdly shaped objects all over the walls. Those are all tools. So the curriculum of learning woodworking through building this house involves learning how to bend wood. That's part of the reason for the roof. Also, that makes the roof sort of its own standalone component. And I'm designing it in such a way that the entire roof can be built from on the ground. And then it gets set on top of the house. Hoisted. Just block and tackle. No big equipment. Very simple. And the bent beams aren't going to flex at a vulnerable joint if we do that. They're, by the time you've either steam bent hardwoods and it's bent and it is now stable, it's a solid piece of wood, it's plenty strong. Or you've laminated, done a lamination bend with a softwood, and it's not going to move either. It is incredibly strong, so we can build the house on the ground, use some lifts, hoist it, place it in, put it in place. Nobody's got to do any of this fancy copper work on a ladder or on the roof proper. It makes it a lot more accessible. The other design choices. So another reason for the timber frame is because it is truly modular. You can take apart a timber frame. There's no metal pieces. There's no holes left behind if you take it apart. It's like giant Lincoln logs. So it's a modular design. With the mycelium panels, those are small. Again, they can be taken apart. They can be flat stacked. This whole design can actually come on the trailer flat and then be assembled. I've learned this from living in a yurt. These yurts are such incredible designs. It's amazing to me that I can pack up my entire house and move it in a U-Haul and then put it back up and it's a house. A lot of that went into this design is how do we make a home that is not tied to the land? You do not have to be a landowner. You should not have to be a landowner to own the roof that goes over your head. So it is home ownership for people who are not landed. It can be landed. It does not have to stay on the trailer. The trailer is not actually its foundation. We're prototyping it right now. The plan is that it will have a convertible foundation. You should be able to, once maybe you start out with it on a trailer because you don't have land. Maybe you achieve the dream and someday you have your own land. And now it's going to become your studio because there's a house. You can take it off the trailer and you can reassemble it on a pure foundation or on a poured foundation, and it can live there, and then the trailer can go off to be used for another house. The trailer does not actually belong to the house. So that's a big part of why we're making the choices that we're making, is because I want to design a home that belongs to the person it houses. It doesn't belong to a piece of land. It doesn't belong to the foundation. It can change as the person changes. Part of this design is that we're making everything inside of the home, all of where you would put utilities, highly accessible to the person who lives there. It should be easy to adapt, to build it out the way you want it in one place. But if you move, if your life changes, if you switch counties and suddenly you find that the regulations are different, oh my gosh, in this county, I can't have a sink in here, but I can have a toilet in here. It's kind of ridiculous how the changes, what is against the rules county to county. which is something that you have to deal with if you are living in rural areas. Everything you know about the rules and regulations of living in urban areas, out the window. It's completely different. So you need, if you're choosing to live this lifestyle, you need to be able to adapt. The reason we're doing it on a trailer this first time is because so far, about every 6 months over the last 2 years, we have faced an unprecedented climate event. This building we're in right now has been crushed by trees before. I've been evacuated because of fires. We had a heat dome that actually burned fruit on the trees. There are lots of things that people have to run from now. And I want to make homes for people that they don't have to abandon. I want people to be able to take their safe spaces with them, even if the place they live is not safe temporarily. So, what we've got is every aspect of this design. If you look at it just one perspective, it looks foolish. But if you look at how marrying all of these things together finally makes them all possible, makes them all make sense, makes it almost just so pragmatic. It just seems like somebody should have done this before. That's what we're trying to do. So, one of the amazing things about growing mycomaterials versus growing mushrooms is that we don't have to cater to the fussiness of gourmet mushroom varieties. We get to use the heavy lifter of the mushroom world. We get to use oyster mushrooms. And oyster mushrooms are such a strong grower that they outpace most contaminants. So when you look at YouTube and you look at people who are growing gourmet mushrooms and they've got these fancy labs and they've got all these separated fruiting areas and they have to worry about all this. You don't have to worry about this with an oyster mushroom. In fact, if you were a fancy mushroom grower, you have to make a choice of whether or not you want to grow oyster mushrooms or you want to grow everything else. Because once you're growing oyster mushrooms, they will try to contaminate everything else. It's just such a hardy fungus. And that's what we get to use because it makes such a wonderful colonized substrate as a mycomaterial, just fluffy and white and strong, and it grows on garbage. And so not only does it grow on agricultural waste, but out here where we live, we have Douglas fir, and the understory of that is largely hazel, beaked hazel, the native hazel, not the hazel that has been brought in for hazel cultivation. And most of that died in a blight. But the beaked hazel has endured. It's very strong, but it's a coppicing hardwood. And so what that means is it's a big root ball, and it grows up all of these saplings, multiple saplings from the root ball, and they're not long lived. They grow really fast. They grow straight. They grow dense. It's great hardwood, but it doesn't get real, girthy before it breaks. And then it just becomes fire fuel. Now, it used to be a really important food source for beavers. We used to have so much beaver out here. And that's what beaver eat. They're the original coppicers. So they'd come through and they'd eat the hazel saplings. And then the next year, that hazel stool, that big root ball, would sprout up new saplings. And it was just this constant rotation of the hazel throwing up saplings and the beavers taking it out and storing it in their dens to eat over the winter, build dams out of the bigger pieces. The beavers kept the hazel young. We don't have beavers now. And so we have hazel everywhere that is just growing fire fuel, and it's being unutilized by anything. So it's not being utilized by beaver. It's just becoming fire fuel, and it needs to be managed. and it can be utilized. The blue oyster mushroom, the just oyster mushroom, happens to love it. It loves it so much. So if you're managing a coppice, and this is something that was really popular, is still really popular in Europe. Before you could just go to Home Depot and buy fence posts, you grew fence posts by maintaining a coppice. The first year, that material is good for basket weaving, those little pieces that the beaver would eat, baskets. The second year, maybe it becomes wattle and fences. The year after that, it becomes small fence posts. If you let it grow and you cultivate it as it's growing, it can be what you want it to be, and you don't have to manufacture a thing. You just let nature grow your material, and you take it out before it becomes wildfire fuel. That's where the goats come in. It's a problem in that you want to be doing that work in the summer, maintaining your coppice, your young shoots. You're not harvesting it in the summer, you're maintaining it. There's a lot of leaf material in there. That also becomes fire fuel, and nothing is eating it. So that's where the goats come in. If we want to be able to get into those areas, we need somebody to come and do the cleanup first. And we could go in there with machines and we could tear up the environment, trying to make it so that we can go in there and maintain the coppice, or we can let goats do what goats want to do while they're filling the niche that has been left open. There's a vacuum there that they want to fill, and they go about doing regular goat things, and they poop all over what they've eaten, and it's really great for the soil regeneration. It's this whole cycle. If something else is waste, is an input, then it's not waste. That's the whole permaculture design. So how do we build a house out of the environment we are in without artificial inputs, without waste outputs? How do we build a house using the ecosystem around us while maintaining that ecosystem for the health of everything? This is the way we have found. It's a green wood timber frame. It's mycelium substrate turned into wall panels. And it's can all become a curriculum to teach other people how to do this, and how to steward forests, and how to live a slower, simpler life. So I think I'm going to end right there. I think I've talked enough, but hopefully I've done a good enough job of talking about the marriage of these many different, design principles and innovations to create something that is actually achievable and could meet so many needs. Please ask me questions in the comments. It would really help me, and I will post updated videos to answer those questions. Thank you so much.